part of sample exercise 19.8 where we talk about, let me get over here to this, there we go, to the Haber process such the N2 plus 3H2 yields 2NH3. This is producing ammonia, which is an excellent fertilizer, which is why they're trying to combine plentiful nitrogen gas and hydrogen gas to get this to work so that they could improve their farming and produce like way more food. So that was the whole idea behind this. So this one's actually a pretty popular chemical reaction. Popular, I don't know, but noteworthy. Assume that delta H and delta S for this reaction do not change with temperature. Predict the direction in which delta G for this reaction changes with the increasing temperature. So we're going to predict. Now, we're going to be using these numbers anyway, so for A, to help show you the prediction, I'm going to go through this and see if we can figure out. So if I'm looking to find the overall like delta H, not formation, of the reaction, you'll sometimes see that as Rxn. I'm going to use the summation sign, which means that I take all of the products, including coefficients, and I subtract that from the summation of all of the reactants. Okay, now this is supposed to be one of those things that we've done before with delta H. I'm not sure, like it was a long time ago. You guys are AP. I'm talking about honors chapter 5. So a long time ago. So let me show you how this actually works. So what it looks like when I go through to do this. So we just take a look at like the size and the magnitude of delta H and what the sign is. And to be able to do that, we need our appendix C that has the delta H, delta G, and delta and the S, the entropy. So we're going to do that for both hydrogen and for delta H and for delta S. So here's what it looks like when I do this. It's not difficult to do. I notice that when I'm talking about delta H, a formation, I have a 0 for this, a 0 for this. If you look at it, and I'll go to it quickly so we can put them all up here. Hydrogen right here, this is the delta H. There's my 0. Nitrogen, the delta H is 0. And only when we get to NH3 gas do we see that we actually have a number that's not 0. So that makes this a whole lot easier, and that's 46.19. So what I do then is I take all of the products, and the way that I do that is take 2 because of the coefficient, and I multiply that by the 46.19, and that is a negative like this, which gives me the number then, the negative 92.38, and this is of course in kilojoules per mole. Okay, so that's my number for the products, and then for the reactants, the summation is like I'm working with the H2, and the H2 is 3 times 0 because there's a 0, and then I add that to, I don't know why my board's getting all funky here, but 1 times, because there's only a 1 coefficient there, times the N2, which is 0. So of course this whole term here ends up being 0. So when I do this, I get a negative 92.38, and that's kilojoules per mole. Okay, so that's my delta H. I'm going to do the same thing, but for delta S, exactly the same thing. The only thing I'm going to change is the numbers that I'm going to use. So for the products here, I'm going to do 2 times, and then I go back here. I'm going to do this in red so you can see the difference. 2 times for NH3. Where are we at here? NH3 is, for delta S, is all the way over on this side, 192.5. So I go back here. I go 2 times 192.5 like this, and then I'm going to subtract that from, now I need a couple brackets here. I got 3 times, and then whatever it is for delta H, for hydrogen, whatever that is, and then I'm going to add that to 1 times, and then my nitrogen like this, and the whole thing is going to be like, that's how I'm going to figure that all out. So let me fill in the numbers here. For H2, I got 130, and for N2, I got 191.5. So let me put those numbers in. So I go back here. I got 3 times 130.58. That gives me, what is that, like poop, where do I have that? 390, I think that's 391.74, that whole thing there. And 191.5 gives me 191.5 for a total of, so I got 3, let me see if I can get this right here, 385 minus, and then this whole thing adds up to, I think it's 570 something. Shoot, let me grab my phone and calculator so I can do this. I didn't actually write that number out. So that's going to be 391.74 plus 191.5 equals 583.24. So 583.24. When I subtract those two, obviously I end up with a negative of negative 198.24. Okay, now it says predict. Okay, this is all still part of letter A. I did all of this so that we could use this information later on in the next part of B, make those problems a little bit easier. But look what I did. I put this graphic down here. This is page, I forget exactly what it is. It's table 19.4, page 828 or something like that. I think it's 828. Notice that I have, if we're looking for delta G, whether it's going to be spontaneous at all temperatures, non-spontaneous at all temperatures, or it could be a plus or a minus, here's what we have. If we have a minus for delta H and I have a minus for delta S, that means that my negative temperature times delta S term is going to be positive. And then you have a negative for delta H competing with a positive. For this you have the negative of the delta H competing with the positive of the negative T delta S, and this gets a little confusing. So at some temperature, this term right here is going to be more positive. It's going to be more positive than the delta H is going to be negative, which causes my delta G to be positive. But so at low temperatures, because this term here is dependent on temperature, at low temperatures, my delta G is going to remain negative, which means spontaneous, but at higher temperatures, it's going to be non-spontaneous. And of course, the question is, well, what temperature is that? Well, you have to compare the delta H and this term of negative temperature times delta S. So we're going to do that. We're going to compare these two. I'm going to show you what it looks like. So for the first one, I'm going to do part B now in blue. Okay, so part B is in blue. And it's going to look like this. It says find delta G at 25 degrees Celsius, which is 298. Okay, so what I do is I do my delta H, and then this is a minus T delta S, like this. I plug in everything that I know, which is negative 92.38. This is kilojoules. It's important that we know it's kilojoules per mole, minus, and then this part here, the minus part, is the temperature is 298, okay, and then times, and then at 25 degrees is the negative. Okay, now here's the part that's a little tricky. This right here, I didn't write this down before, but this is in joules per Kelvin. So to change this to get kilojoules, I need to move the decimal place 3 places to the left to make this number smaller. So that's a negative 0.198, like that. Not 0.24. You can't have 2 decimals in the same number, idiot. And then that is joules, kilojoules per Kelvin, like that. So I moved the decimal place over so that we could do these two terms like this. So when I do these two terms and I get what I get is a negative 92.38, like this. Minus, it's minus a minus, which means plus plus. So that's plus, and then this whole thing here, you get a negative, which is going to be a plus, 59.0. So 59.0 I think it's 59.0. It's something very close to that. And then what we get here then is a negative 33.4, and that's kilojoules, like that. Kilojoules per mole, just kilojoules. Okay, so this right here is a negative. This means delta G is spontaneous, that the reaction happens spontaneously. Negative 33 kilojoules. So what happens when we increase this temperature from 298 from 25 degrees Celsius now to 500 degrees Celsius, which when we add 273 to it is 773 Kelvin. Well, I go through exactly the same thing. Here is at 500 degrees Celsius. So my delta G, and I'm going to have to move this thing down even further. Okay, give me 1 second here to do this. I'm trying to make this as quick as possible. Okay, don't mess with me. There we go. Delta H is still the same, 92.38 kilojoules minus T delta S. Here's where the difference is. Minus, and then 773 times negative 0.19824, like that. And then here we get a much larger number. Let me grab my calculator so I can be done with this. So 0.19824 times 773 equals, now look at the difference here. I got a positive, because this ends up being a positive, 153.9, I'm sorry, 0.24, like this, and this is a negative 92.38. So what happens here is we end up with a 60, positive 60.9 kilojoules, and that is non-spontaneous. So somewhere in between 25 degrees and 500 degrees is where it goes. The delta G goes from being negative to positive, which means it's non-spontaneous. Okay, that's part A. Stay tuned for part B.